USIU CTF was quite fun. I wrote a blog post for the whole CTF. On this category, we have the pwn challenges, and I'll be going to do a vlog on one of the pwn challenges called buffer. So I'll link this on the description, so don't worry, and also comment down there if you want the binary, so that I'll share the GitHub link. Listing our current directory, we have basic buff binary, and we can check its file type using file utility. We see it's a 64-bit least significant byte executable, and it's dynamically linked, so basically the object files are linked on it. As you can see, we have its interpreter here, or the loader. We can use this command to check the loader and its libc. So having that, we can use Radare in debug mode to check its basic functionality. So the way we analyze the binary in the Radare, you can use AAAs, or also you can use them as an argument here. So AFL, this is analyze the function and then list them. So you're analyzing the whole functions of the binary, and then we are listing them. We have a main function, we have a gets function there, so it's a symbol, some symbol there. We also have the exec.We, so that's another libc function, and then we have a user defined function called getFlag. So this is pretty much it, and we can seek to main. So what that means is that we are changing I guess our current location to the function main. So from there we can use PDF. So this is print the disassembly of the function we are in. So we can see we are using gets, and then we have a local variable that was defined up here. So the reason I'm calling it a local variable is because it's rbp -1, so basically that's a local variable. Remember, RSP is really small than RBP, so basically when you subtract something from RBP, you are in between the RBP and the RSP, so that is a local variable. So after using gets here, we have a local variable that is compared to hex4d. So to spoil the fun, we can use Python 3 interactive console, and we can use the chr function. So checking hex4d, we get its character m. So basically, if this variable has character m, then we are not going to follow the jump not equal, so we are going directly to the system.getFlag function. So remember, this local variable here had 0 in it, so let's print the disassembly of the symbols.getFlag, and we can see that it's calling the system exec.We function, which takes this as the argument, and basically if that happens, we get a shell. So we know what this binary does. So yeah, the next thing we need is my pwn script template, which I can just do like pwn script and then give it the name, so that it will substitute for it in the script. So we can use vim, and we can see that the elf is already substituted there, and yeah, so we can launch that. So we want to define our payload, but now we don't know what to send, so let's execute the binary, and we can see it waits for our input. So let's send a couple of A's, and that's it, it quits. So what about if we send a whole dump of maybe 300 A's? So dump is an alias that copies 300 A's to my clipboard. So if we run buff again, we get a segmentation fault. So basically we need to get the offset so that we can place m right after our gibberish. So we can use GDB for that, and then we can launch it in quiet mode. We can set the disassembly flavor to Intel, then we can set pagination to off. We can disas main, and as you can see here, we are subtracting hex 70 from RSP. So basically the buffer is about hex 70 long, and then we can see that the variable that is being compared to is subtracted 1 from the RBP. So basically, I guess from there to the top of the stack is hex 70 -1. So let's use Python for that. So this is supposed to be hex 70 minus hex 1, so this one 11 and this the offset. So I'm just going to define the offset here. So the offset equals to 111, and we need to send some, maybe an obsled, I guess. So you multiply by 111 and then you can add the Radare, so that is hex 4D. So from there we need to be in interactive mode. So let's see. Yeah, so we cannot concatenate string to byte, so let's rectify that pretty quick. Yeah, and okay, that got pretty bad, so I don't know why that failed, but I know why. So we didn't send the payload, so we just need to use send and then p.send. So p is the resource, that is the resource that is running the binary, the process, and then we use send to send the input. So yeah, and we have a shell. So it says term environment is not set, so you can export term equals to xterm. So yeah, something like that. And we have a shell. So the next thing I want to try to do is go the old fashioned way, where we are not using the Pwntools, we will be using the socket library, something like this. So like import struct, something of sort. So I guess this will be pretty fun. So I have a template also for that. So you can just say the socket script and then give it the interface. And before we give it the interface, actually, we can try to do something like start this binary in a server way. So where we will need to connect to some port, where if we connect to that port, we are basically executing that binary. So for that, I'll use ynetd, and then I'll execute this on the lead port. So okay, we need to define the port there. So here I'll just use stack 0.0.1, then the lead port there. So we can vim the socket script, and then the thing we want to do here, we want to like send so I'll explain the script not right now. And then we need struct module, so struct.pack, and then something like that. From there we need I guess this is it, and yeah, so we can execute that. Not sure why that is not happening. So what I'll do is, let's debug the script. Okay, so we don't need that, and we don't need that, of course. So yeah, and we have a shell. So we can see the error here, term environment is not set, and that's why clear command is not working. So let me explain the script. So the first thing you are doing with the script is importing the socket library, time, struct, and telnetlib. So what telnetlib will allow us to do is interact with the binary interactively. Socket will allow us to connect to the binary that is being served on port lit. So this is the syntax here, and then we are using the telnetlib module. From there you are sending the input, and we are just including this to be like an enter key, or we can also use something like car, I guess it will also work. So yeah, so then we are using the s.send. so basically remember, s is the resource that is connected to the network, and so using s.send, that will send our payload, and then we are using the t.interact, and we are also closing the binary after we work on it. So let's see. Yeah, still works. So yeah, like I said, that still works. So if you enjoyed this video, you can share it with your friends, and watch out for more videos like this one, because I'm making a series of binary exploitation challenges that will mostly appear in CTFs. I'll also link down my blog, so you guys go follow my blog kindly, and see you next time.